Welcome to continued instruction on derivatives of exponential and logarithmic functions. Okay, we left off after example 5, and now we're coming up to logarithmic differentiation. Now, what does that mean? Well, it's saying, I'm just going to read this to you. Unfortunately, we still do not know the derivatives of functions such as y is equal to x to the x, or y is equal to x to some power, which would be a chain rule of x to the x. These functions require a technique called logarithmic differentiation. Okay, we're leaving that one. Differentiation, which allows us to differentiate any functions of this form, function to a function. Alrighty then, here are the rules. You can read through those, but I'm going straight to the example. Okay, so find the derivative of y is equal to x to the cosine of x. And you're like, all right, here's the first step. You want to take the natural log of both sides. So you can look up to the steps, and we're just going to go through those. So what would that look like? It would look like the natural log of y is equal to the natural log of x to the cosine of x. And you're like, well, what does that do for us? Well, it allows you to take that cosine of x and bring it in front as a multiplier with your properties of logs. So you're going to have cosine of x times then the natural log of x, and you're like, well, that's great. Now what do we do? Well, at this point, what we're going to do is we're going to take the derivative of both sides, which involves change of color. Okay, so whatever you're working with, change that color. And if you take the derivative of this side right here, so basically, remember, we're doing this derivative with respect to x, so it's going to kind of involve a little bit of implicit differentiation since we do not have this solved for y. So what that will look like is the natural log of y, the derivative of that would be 1 over whatever that inside function is, left unchanged, which is y in this case, times then the derivative of y with respect to our variable x. So that's what that will look like there. Now on this other side, we've got a product between these two, so we're going to let the product rule lead our way. And so the derivative of cosine is going to be the opposite of sine of x. So that's f prime times g, which is natural log of x left alone, plus cosine left alone, times the derivative of natural log of x, which is just 1 over x. And there you go. Now the next step is going to involve taking, I'm going to change color. What do you guys like? A little bit of baby blue. Okay, so reason I'm doing this is I want to show that now I'm going to take both sides and multiply by the y, because what we want to do is solve for dy dx, because that's what we're looking for, is the derivative of y, which is denoted dy dx with Mr. Leibniz notation. Okay, so multiplying by y on that side means we need to multiply by y over here as well. And you're like, this just looks a mess, and it kind of does, but watch, it's going to get party in a minute. So now you have all of this, and it's times y, and you're like, well, this is not the derivative of y with respect to x, because I got a y over there, but you know, again, implicit differentiation we did, but here's what you can do instead with this, is you can replace the y with what it was originally equal to, all in terms of x. And so what that would look like is big old parenthesis, opposite of sine of x, times natural log of x plus cosy x times 1 over x times then x raised to the cosine of x, just like that. And then potentially we can simplify this. I'm going to pause and let you guys simplify, see what you come up with. I'll see what I come up with. Pause. So you should have figured, kind of like I did, that there's really no simplification. I just moved this in front, and then I switched these terms so there was minus in between, and like I've said before, it's just a little bit of personal preference. All right, so there's that one. Moving on. This one's asking you to find the derivative of y is equal to bleh, all of this, right? So is this going to involve, I'm assuming it's going to involve logarithmic differentiation, but why would that be? Why do you suppose it would be? Well, in this particular case, it's really just a big bunch of mess, and we're just going to show how you can use this to break all of this apart term by term rather than have this huge quotient rule. So if you're going to take the natural log of both sides, you'd have the natural log of y is equal to the natural log of all of that, right? So let's go ahead and write it. So e to the x cosine to the 4. Okay, so we're taking the natural log of that. So over on this side, we're just going to keep this, and then we're going to pull this apart. And so you've got the natural log. We're going to use properties of the logs. We're going to take these. This will be a positive, this will be a negative, a negative. So basically what I'm saying is you'll have the natural log of x counted positively because it's in the numerator, and then the natural log of the square root of all of that, which we can, actually I think I'm going to pull that ahead. See how that's a square root? I'm going to go ahead and pull it in front with the 1/2. So it'll be 1/2 natural log of 3x plus 4. So we're just expanding this little algebra. And then the two that are below will have negative values, so it'll be natural log of e to the x minus, and I'm going to go ahead and pull that 4 in front of natural log of cosine of x. So stopping right there. I'm not sure I have that parenthesis. Do I need it? No, it's just like, it's just like natural. Like put a parenthesis at the end. I don't think we need it. Okay, so at this point, what we're going to do is we're going to take the derivative of both sides. So I'm going to do that in blue. So it will be derivative of this side. Remember, using implicit differentiation, it'll be 1 over y, and then it will be dy dx, which is derivative of the outside function, leaving y left unchanged, times notation for the derivative. Okay, so term by term, we can take the derivative. So this will be much simpler. Natural log of x is 1 over x. And then we're going to leave that constant multiplier there, and it'll be 1/2. And then the derivative of this is going to be 1 over that, which is 3x plus 4. And then times the derivative of that, which would be just 3. So that would multiply in. So I'm just going to fix that to be a 3. Takes care of that. Moving on, we got natural log of, basically the natural log of e to the x, we can just simplify to equal x. So we could have done that before. Natural log of e to the x is x. And so its derivative is -1. So that saves a little bit. And then we've got the 4. Let's see, anything else we can do in there? No. This is by natural log of this. That's why I needed a parenthesis right there. Do you see that? Okay. I'm like, what's going on? Natural log of what? Okay, so then that's a -4 is the constant multiplier. These things happen, and it's kind of, like, I'm not going to redo the video because it's a good thing to see that sometimes you miss things, and as you go back through them, you find it, and that's part of math. So that's your multiplier is -4 times the derivative of the natural log, which is going to be 1 over x, but it's a chain rule, so it's cosine of x, and then chain on the derivative of cosine, which is, in parentheses, opposite of sine of x. Okay. So we're going to go in there and clean that up a little bit, and then we're going to multiply the y over. So in doing that, I'm going to multiply the y over, so it's going to end up being dy dx on this side. I'm going to put the y in front here, so it'll be y times all of this. So that's 1 over x. That's cool. I'm just going to rewrite that as a 3 up here and distribute that 2 through, making it 6x plus 8. That -1. Really, there's no constant here, so we'll just keep it. All of this right here can turn into, this is a negative and a negative, so it's positive, and it's a 4, and then this is sine over cosine, so let's just make that 4 tan x. Okay, so what's the last thing that we need to do is replace this y with what it is equal to. And as I'm rewriting this, I just want you to say you could have done this derivative with the quotient. It's just giving you another option right here. So I'm going to put in place of y that whole thing, and then we'll be done. So nobody said it was going to be pretty. I don't know. I think it's beautiful. I think it's a work of art. What do you think? All right, so this is 6x plus 8 minus 1 plus 4 tan x. Booyah. All right, and we're done. We're done with this section, and we're done with the lesson 4. I just want you to know, let me go back up real fast to point this out. I thought that I had an example using, that looks weird when it does that, using the log base b, but it's really actually pretty easy. So I'm just going to address it real fast right now. Say that you had y is equal to log base 2 of x and you want to take its derivative would then be dy dx is equal to. All right, so we're just going to follow this little format. It would be 1 over your x and then times the natural log of whatever the base is, which is 2. So that's it. Okay. They don't come up too often. Usually we deal with natural log. All right, there you go. Bye-bye.